A spring with a mass of 2 kilograms has natural length of 0.5 meters. A force of 25.6 newtons is required to maintain it stretched to a length of 0.7 meters. So M is equals to 2 and force F is 25.6 newtons. Now from Hooke's law, F is equals to K times S, where S is the stretch. Now if you read the question again, S is actually 0.7 minus 0.5 and this is 0.2, and so we have 25.6 is equals to K times 0.2, and so K is equals to 25.6 divided by 0.2, and this will give us 128. So we can plug this into our equation, which is mx double prime plus beta x prime plus kx is equals to f of t. Now in this question there are no external forces and there is no damping force, so this is really a question of free undamped motion, and so we get 2x double prime plus 128x equals to 0. Now if I divide through by 2, I get x double prime plus 64x equals to 0, and so the auxiliary equation is m squared plus 64 is equals to 0, and m is therefore equals to plus or minus 8i. And because these are complex roots, we obtain x is equals to c1 cos 8t plus c2 sine 8t. Now I'm going to differentiate this so that I can put in my initial conditions, and this is minus 8 c1 sine 8t plus 8 c2 cos 8t. So to obtain the initial conditions, let's read the question again. It says the spring is stretched a further length of 0.7 meters and then released. This means that x of 0 is 0.7 with initial velocity of 0 means that x prime of 0 is 0, and so we can put in these initial conditions to obtain the values of c1 and c2. x0 is 0.7, and so we get 0.7 is equals to c1 since sine of 0 is 0. Next, x prime of 0 is 0, and so we get 0 is equals to 8c2, and so c2 is equals to 0. And now we get our final answer. X of t is equals to 0.7 cos 8t, and this is the final answer.